Hello, my name is Rashed Hassan. My edX username is 4cuz, and my GitHub username is 4cuz. Today's date is November 19th, 2025, and in this presentation I'll be discussing a real-world security incident that occurred between March and June of 2024. I chose the topic of the Snowflake 2024 Credential-Stuffing Breach because it connects very strongly with several core topics we studied in this cybersecurity course, including authentication systems, encryption, account security, password attacks, network monitoring, cloud security, and incident response. This incident is important because it demonstrates how even global companies with advanced cloud systems can still experience large-scale breaches when basic security layers are misconfigured. In early 2024, several major companies around the world, including Ticketmaster, Santander Bank, and many others, reported that sensitive customer data had been stolen from their Snowflake cloud environments. The attack was not a software vulnerability or a zero-day exploit. Instead, it was based on credential stuffing, a very well-known technique where attackers use leaked or stolen username, password pairs from old data breaches and test them on other online services. In this case, attackers were able to identify Snowflake accounts where companies had disabled multi-factor authentication and where employees had reused passwords that had already been leaked on the dark web. Because Snowflake allowed customers to disable MFA on certain accounts, the attackers simply logged in as legitimate users. Once inside, they accessed large data warehouses, ran SQL queries, extracted massive datasets, and attempted to sell that information online. To understand the scale of this incident, it's important to understand what Snowflake is. Snowflake is a cloud-based enterprise data warehouse platform used by thousands of corporations around the world. Its purpose is to store, process, and analyze extremely large datasets. Many organizations use Snowflake to centralize customer details, financial records, transaction logs, data analytics, machine learning datasets, supply chain data. Because Snowflake hosts such sensitive datasets, a single compromised account can expose millions of records. The attack wasn't on Snowflake's core systems. Instead, attackers accessed customer accounts that were poorly secured. This distinction is important. Security in the cloud depends not just on the cloud provider, but also on the customer's configuration of their own environment. The attack followed a straightforward but highly effective chain. Step 1. Password collection. Attackers collected massive lists of leaked passwords and email addresses from previous breaches. These lists are commonly sold on the dark web or shared on hacking forums. Step 2. Credential stuffing automation. Using automated scripts and tools, attackers attempted to log in to Snowflake accounts using these leaked credentials. Because credential stuffing bots can run thousands of attempts per minute, this is extremely efficient. Step 3. MFA misconfiguration. Many Snowflake customers had accounts, including service accounts and testing accounts, where MFA was disabled. Once attackers found a password match, they gained direct access with no secondary authentication barrier. Step 4. Access and data extraction. After logging in, attackers used Snowflake SQL interface to run queries like select asterisk from customer_table. They exported entire tables, compressed them, and stored them in external locations. This chain shows how a simple configuration weakness, disabling MFA, enabled a very large breach. This incident occurred because of a combination of authentication failures and poor configuration choices. Here are the key technical points. 1. Lack of MFA enforcement. Snowflake did not require multi-factor authentication for all customer accounts. Some companies removed MFA for convenience, especially for service accounts used by scripts or older systems. 2. Password reuse. Employees reused passwords that had already been leaked in unrelated breaches. Attackers simply tried these old passwords on Snowflake and found matches. 3. API key mismanagement. Some Snowflake accounts used API keys that had not been rotated for months or even years. These keys were extremely valuable once attackers gained access. 4. No IP restrictions. Companies did not enforce IP allow lists. That means any IP from anywhere in the world could log in, including the attacker's proxy networks. 5. Weak monitoring and logging. Even though Snowflake logs all queries, many companies were not actively reviewing their logs. The attackers had days or weeks to run queries unnoticed. None of these issues involved complex hacking. Instead, they were failures in identity and access management, one of the core topics of this course. The attack succeeded for several reasons. Human error. The biggest factor was password reuse. Humans tend to use the same password across multiple accounts, so once attackers found a match, everything else became easy. MFA not enforced. Multi-factor authentication could have stopped this entire breach. But because customers were allowed to disable it, attackers were able to walk right in. False sense of security. Companies believed that because Snowflake is a major cloud provider, their accounts were secure by default. However, security is shared. Snowflake provides the tools, but customers must configure them properly. Lack of zero trust principles. Zero trust assumes no account or login attempt is trustworthy. Many Snowflake customers used old, privileged accounts with far too much access. Insufficient monitoring. Snowflake logs suspicious login attempts, but many organizations were not reviewing these logs or using automated alerts. This breach shows how modern hacking often relies not on technical vulnerabilities, but on exploiting human weaknesses and convenience. The breach was extremely widespread. Some of the major affected customers included Ticketmaster, approximately 560 million user records stolen. Santander Bank, around 30 million customers impacted, including account information. LendingTree subsidiaries, multiple large financial datasets were taken. Advance Auto Parts, sensitive operational and customer data exposed. Neiman Marcus, corporate and customer data leaked. Attackers attempted to sell this stolen data on underground marketplaces. The financial damage, reputational damage, and operational disruption were severe. This incident relates directly to many topics from our cybersecurity course. Password security and why hashing is not enough. Authentication systems, especially MFA and session tokens. Credential stuffing as an attack method. Cloud security principles. Access control and least privilege. Network-level restrictions and IP allow listing. Log monitoring and intrusion detection. Threat modeling and identifying weak points in a security architecture. Defense in depth. Zero trust models. This incident is a perfect example of why these concepts must be applied consistently. Even advanced cloud services cannot protect organizations if authentication is weak. To prevent attacks like this, organizations should enforce the following. 1. Mandatory MFA for every account. No exceptions, including service accounts. 2. Strong password policies. Require unique passwords that are long and complex, with automatic detection of compromised passwords. 3. Dark web monitoring. Organizations should routinely check if employee emails or passwords appear in breach databases. 4. API key rotation. Keys should expire automatically and rotate every 30 to 60 days. 5. IP allow lists. Only approved networks should be able to access Snowflake. 6. Zero trust strategy. Assume every login attempt is suspicious until proven otherwise. 7. Continuous logging and alerting. Set automatic alerts for unusual query patterns, large data exports, or foreign IP logins. In conclusion, the Snowflake 2024 breach highlights a critical lesson. Security failures often come from simple misconfigurations, not complex vulnerabilities. Even the most secure cloud platforms are only as strong as the authentication methods used to access them. The attackers didn't use a zero-day. They didn't bypass encryption. They didn't hack Snowflake. They simply logged in with valid credentials because organizations allowed weak authentication practices. This incident reminds us that the fundamentals of cybersecurity, strong passwords, MFA, zero trust, and monitoring, remain the most powerful tools we have. Thank you for listening.